The differentiation rule for natural exponential functions. All right, this is one of the easiest. I'm not even being funny. This is one of the easiest rules we've got. All right, so remember the d dx is the derivative, right? Of the natural log. All right, so e to the f of x. So Euler. All right, you ready? This is how easy it is. I'm going to take a seat. It's so easy. All ready? So literally, when we are doing these, okay, e to the f of the derivative of e to the f of x is literally itself times the derivative of f of x. And that's it. Okay? So nobody should miss the first part because you're literally copying from the problem. Has everybody got me? Okay? And then the f of x shouldn't be super difficult. So let's jump right in. So example 1, letter A. All right, e sine of x. So f prime of x here is going to be, what is the entire function? E to the sine x, right? Times, what's the derivative of sine x? Boom. We're done. Now, the only thing I will say is I'm going to write that with cosine x in the front. Do you have to? No. Okay. But I did. And we're done. That was it. All right, letter B. Okay, so G prime here. Okay, so what is our function? E to the 2x plus 3 times the derivative of 2x plus 3? 2. So how am I going to write that?
2e 2x plus 3.
Perfect. And we're done. Anybody lost yet? We good? Cool. All right, letter C. Bless you. What do you think on C?
3e to the 2x times 2.
Times, what'd you say, times what?
2.
Times 2? Mm-hmm. Yep, so 3e to the 2x times 2, which gives me what? 6e to the 2x. Now, you could have done the product rule with 3 times e to the 2x, okay? But remember, for a product rule, you take the derivative of the first. What's the derivative of 3? 0, so that's going to cancel that out anyway. So you don't have to do that. Is everybody with me? Okay. All right, ABC. Easy as 1, 2, 3, right? Letter D. All right, j of x is 2x plus 3 times. Okay, so here we do have to do the product rule. Okay, so we're going to start with derivative of the first times the second, right? Plus the derivative of the second, which would be what? Times 3 times the first. Bless you. All right, so let's kind of clean this up. So that's just going to be 2e to the 3x plus, that's going to give me, so that's going to be 3 times that, right? So that's going to be 3, that's 6x. So 6x e to the 3x and 9 e to the 3x. All right, so which one of those can we combine? 2 and 9. So our answer is going to be 11 e to the 3x plus 6x e to the 3x.
3x times 3 is 24.
Okay, so if we were just doing this like we did here, right? So the derivative, so it's the e to the 3x itself times the derivative of f of x. So just like a, b, and c. So like if the problem was just e to the 3x, it would have been e to the 3x times the derivative of 3x, which is 3. You with me? So when we took the derivative of e to the 3x, it has to have both. All right. Okay, letter E. Product rule again, right? Okay, so derivative of the first, 2x times the second is just e to the 2x plus, all right, so the derivative of the second this time is going to be e to the 2x times 2. You with me, Ashton? You with me? Okay. Where'd it go? Nope, not there. Right there. Okay. So simplify this out. What do we get?
2x e to the 2x
Uh-huh.
plus 2x e to the 2x plus 2.
Okay. So I'm with you on the 2x e to the 2x. So right here, that's just 2x e to the 2x, right? So this is going to be 2 times x squared. So that's going to be 2x squared e to the 2x. Now, this right here is perfectly fine, okay? This is perfectly fine. But if it was multiple choice, they could have factored out the e to the 2x. You would just go, just depending on what your choices are. Okay, so like I talked about in your warm-up today, when it's multiple choice, they might have it factored further or not. But this is perfectly fine to turn in as your answer.
When you multiply the x squared by e to the 2x times 2, wouldn't the squared or the 2 exponent power be added to the 2x?
No, because their base isn't the same. This one has a base of e, and this one has a base of x.
Okay.
Are you with me, though? I mean, that's not a bad question. It's a great question. But in order to add our exponents, we have to have like bases. One has a base of e and one has a base of x.
Okay.
Okay?
So what do you do with the x with 2 over that?
This one,
No, x squared. Okay.
right here, I did this 2 times x squared and just put it to the front like a constant. You could have done e to the 2x. Like you could have written it, you could have done this. You could have done 2x e to the 2x plus e to the 2x times 2 times, I mean, you can do it either way. I just try to make it look a little prettier by putting these two together and putting it in front of my e to the 2x. So ultimately, all of this right here was multiplied. E to the 2x times 2 times x squared. So I just multiplied the 2 times x squared together and put them in the front of the e to the 2x. Yes, sir.
Would it still be the same if you multiplied 2 to the e to 2x first before putting the 2 to the x squared? So
Like 2e 2x.
like instead of distributing that 2 to the x squared, what if you just did like multiplied it to the like inside the parentheses first, like 2e to the 2x times x squared?
That's fine.
Would you still get the same thing?
Yeah, and that's what I'm saying. Like you could have done 2x e to the 2x plus 2e to the 2x times x squared. And you don't even have to have that dot there. I mean, it's ultimately the same thing as you know it's not a power. But it still doesn't change any of your powers. Your powers will all be the same because your bases aren't the same. Just like if it's 5 times 2 and 2 times 5, we can write it in any order. I just try to write it in the way that looks the most visually appealing, which is this one to me. But ultimately, mathematically speaking, they're all the same in any order. I will say, if y'all are going to try to leave it anything like this, I would probably go in here and start to add like some parentheses instead of, do you see what I'm saying, to separate your terms, just to make it a little bit easier to see. That's just personal, like, preference. Ultimately, remember, somebody else is reading your handwriting, so just be careful. All right, letter F, what we got here? How do we write this normally? E to the 2x minus 6 raised to the 1/2, right? Okay, well, let me ask you this. Using the power rules that we all know, right? Because we learned them in AP Pre-Cal in Test 4, Lesson 1, whenever y'all did that. Using our exponent rules, what do we do with power to a power here? Okay, so if I did that, then what is half of 2x? X. What is half of 6? So I could rewrite this as e to the x minus 3 using my exponent rules that we all remember from Pre-Cal, Test 4, Lesson 1.
It's been so long.
Wait, so you just multiplied like the half times the 2,
Mhm.
and then the half times the negative.
So basically you're doing 1/2 times 2x minus 6,
Oh.
like that. Okay, so now we got e to the x minus 3, which is just prettier for me to work on. Okay, so g prime of e to the 2x minus 3 takes us back to just our regular differentiation rule for natural exponents. So what do we have? E to the x minus 3 times, what's the derivative of x minus 3? 1, which gives me my answer of just e to the x minus 3. Okay, so no product rule required there because we weren't multiplying anything to that natural exponential function.
What happens if you have regular square root, like a cubic root? Would it be better to multiply it or to do it like a quotient?
Probably just your power rule and then go from there. Like if it was a 1/3, it wouldn't divide. Yeah. I would just do the power rule with that and then differentiate from there. Yeah. All right. Last one, G, down here. Sorry, he was stuck down here. I'd done so much work, I didn't realize he was there. So here we're going to use what? We've got to use the quotient rule because we've got a quotient, okay? So let's talk about that. I'm trying to make it a little bit clearer, y'all. I don't know why it's so
Did you
blurry.
resume your video?
I did.
I'm making sure.
Yeah.
I want you to preserve it.
No, you're good. All right. Okay, so, all right, quotient rule. So we're going to do ho-de-hi, hi-de-ho, right? All right, so ho is 3x squared. D-hi, what's that?
5.
All right, so e to the 5x times 5. I'm just going to do it that way because that's the way the rule writes. I will simplify it. You can simplify it if you want to immediately. I'm cool with that, but I just wrote it out the way it is, okay? All right, and then hi, d-ho, 6x over ho-ho. All right, so now I need to, hold on, let me make him not part of this problem because it looks like he is right now, sorry. All right, so let's simplify that out. So 3 times 5 is going to give me 15. X squared e to the 5x minus 6x e to the 5x all over 3x squared squared, right? Which is 9x to the 4th. All right, now, is there anything that can cancel? We can cancel it, at least one x. What else? A 3. Okay. If y'all want to write that out, I will write it out. I'm going to write it out in my next step, okay? But I don't usually write that. I look for what I call a cancellation triangle, okay? Which means we've got a triangle here. We've got 3 terms, correct? I look, is there anything that will divide into all 3 terms? So immediately I saw the 15, 6, and 9, and I knew that 3 would go into all 3 terms. Okay? And if I do that, it's going to cancel out of all 3 terms. The 3 will. It'll reduce all 3 terms. Okay? And then also I see I've got an x squared, I've got an x, and I've got an x to the 4th. So they all 3 have x. So if I take one x out of here, what am I left with? X. This one will be gone, and what am I left with here? Okay. Now I'm going to write that out But normally I don't write that out for myself. All right, so basically we're factoring out a 3x is what we're doing. Okay, and when I do that, I'm left with 5x e to the 5x minus 2 e to the 5x over, oh, that stays the same, 9x to the 4, sorry, because I haven't simplified yet. Now, you might be saying, well, why didn't you take out the e to the 5x? Well, because it's not going to cancel with anything, so that's the only reason I didn't factor it out, which is another reason why I don't normally write this step. I just do it in my head. Okay, so the 3 and the 9 cancel, leaving me with a 3 on bottom. The x cancels, leaving me a q on bottom. So now I have 5x e to the 5x minus 2 e to the 5x all over 3x cubed is my final answer. Yes.
Whenever you factored out that 3x,
Mm-hmm.
why didn't you take it from the bottom? Can you not take it from the bottom, like the 9x to the 4?
I could have.
Oh.
I could have. But ultimately here, I just reduced here.
Oh, okay.
So if you wanted to factor it out of the bottom and have that 3x written there and then have the 3x cubed next to it, then the whole thing would just cancel and you'd be good.
Oh.
Like you could have, like, so you're saying why didn't I just come down here and do 3x and 3x squared? Or cubed, right? Sorry, cubed.
Yeah.
And then if you did that, then yeah, you would just cancel these two and you're still left with the same thing I'm left with. All right. Calculator's coming, y'all. Hold tight. Calculator's coming. All right. Differentiation. This one's not another hard law. So d dx of, all right, natural logs are ln's, right? So ln f of x. This is another one that's pretty simple. We'll start with the bottom. The bottom is just your function. The top is just the derivative of your function. So natural exponential functions and natural logarithmic functions are your two most friendly ones. All right, so here we go. F of x is ln of 2x plus 3. Okay, so I'm literally, y'all, I'm going to start with the bottom because the bottom is just the exact same. So what is it? 2x plus 3. Then what's the derivative of 2x plus 3? There's your answer. All right. The bottom is the same, so 3x squared plus 2x. What's the derivative of 3x squared plus 2x? 6x plus 2. There's your answer. We good? All right. Okay, so the bottom stays the same. What's the derivative of cosine? Negative sine. Can that simplify to what? Negative tangent, yeah. Every time I write negative tangent, it just looks like a really long T and it makes me mad. So then I have to put a negative somewhere else. Like seriously, it happened on my paper over here too. All right, how am I gonna write letter D? 2x minus 4 to the 1/2, okay? Oops, sorry. Get that over there where y'all can see it. Okay? So, the bottom's easy still, right? What is it? And you can either do that to the 1/2. You can leave it the radical because we can have radicals for in calculus. So, either way. All right, so I'm just going to leave it the square root of 2x minus 4. The only reason I changed the top is because what do I have to do on the top? I got to do the derivative, and how do I do that, though? The chain rule, okay? So I'm going to pull the 1/2 down, right? So the derivative So 1/2 times 2x minus 4 to the negative 1/2 times, what's the derivative of 2x minus 4? Times 2. All right? Makes life pretty easy to begin with, because what happens to my 2's? So is everybody with me, that 1/2 and that 2? They're going to cancel. Okay, so now I have 2x minus 4 to the negative 1/2 over the square root of 2x minus 4, right? Okay, well, 2x minus 4 to the negative 1/2 is basically the square root of 2x minus 4 where? In the denominator, right? We move it down. Those exponent rules that y'all remember from test 4, lesson 1 in pre-calculus. Okay, so we're going to move that down. So ultimately now what I have is 1 over the square root of 2x minus 4 times another square root of 2x minus 4, which gives me what? 1 over 2x minus 4. If anybody ever actually watched this video, they would be like, okay. All right. Now we get to the fun stuff. Okay. All right. It doesn't matter which calculator you use. I'll pull both of mine up here. Okay. And I am going to do this both ways. Now, I'm going to be honest with y'all. My preference on how to do this is going to be the home screen method. That's going to be my preference. Okay. You can do it on the graphing way. And I do one of them the graphing way just to show you. But my preference for this, using the TI-84, is on the home screen method. But it's completely up to you. All right. So just understand this. And I don't know. You just might have to play around with your calculator, because I'm not sure how yours works with reference to ours. Do you want one of ours too? Do you want one of these? Okay. All right. Sorry. I don't have that calculator. All right. So when y'all do this, when we start to hit these, okay, it's going to pop up something that looks like this. I think it's let me see. Hold on. I think it's x equals it. Is it x? Does it automatically give you an x there? Or does it give you a block? So 2 blocks? Okay. I couldn't remember if it was 2 blocks or 1 block. All right. So that's what it's going to look like. So we're going to fill in all these blocks is ultimately what we're going to do. We're going to hit enter. It's going to give us an answer. That's how it's going to work. Okay. But you got to fill in the blocks correctly. All right. So for each of the functions below, find the value of f prime of x at the indicated value of x using the graphing calculator, then determine if the function is increasing, decreasing, has a horizontal tangent, or has a vertical tangent, and justify your answer. Okay, so first of all, because we're starting to use trig functions down here, what do we want to make sure our mode is? Radians. Okay, so do make sure that you are in radians. Okay, all right, so here we go. All right, so we want to find the derivative of 3 e to the x sine x, right? All right, so let's see what we got. We're going to hit math 8. Now we have all these lovely blocks. All right, so we're using x, so we want to put an x there. And then we're going to type in our function. Now, you've got to be careful about your parentheses, because y'all know some of these buttons, when you hit them, it opens a parenthesis automatically, right? Like if y'all hit sine, it opens a parenthesis. Okay, so you got to make sure to close that. You got to make sure you're squaring in the right place and all of that. All right, so we're going to do 3 e to the x. Get out of that. And then sine x. Okay, so I've got to close that parenthesis. That parenthesis closes that parenthesis. All right, everybody good? And then we want x to equal -2. And there's your answer. What do I do with that? She said, what do I do with that? Well, we're going to write it down. That's the first thing we're going to do. Okay, so we're going to write it right here. We're going to say that f prime of -2 is was negative 0.5381. Okay, so what does that tell me about the graph of f of x? It is decreasing, right? So f of x is decreasing because why? F prime of negative 2 is less than 0. Okay, so y'all follow this. I don't need to use the yellow. Do I need to use the yellow one? Is it the same on yours as it is this one? It looks the same, right? Okay. All right. So same thing. So same function here. So remember, you can just go up and highlight that function and hit enter. You don't have to retype the whole thing in. And then I want to change that negative 2 to a 1. So I'm going to delete that and make that a 1. How'd I do that? Hold on. Okay. Just go up and highlight your function and hit enter. And it pastes it down there for you. Then just arrow over. Now I don't need the negative. So you can hit delete on the negative and overtype the 1. We good? And then hit enter. So our answer is 11.2681. So f prime of 1 is 11.2681. So what do we know? F of x is increasing because f prime of 1 is greater than 0. Boom, 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 boom. Everybody happier now? All right. So let's see what we got here. Letter C. Okay, so we want pi on 3, right? All right, so math 8 x. All right, so we need to put in, all right, what is that? ln cosine x, close that, over, oh, I didn't close that one, over x squared. Close that, close that, close that. All right, we're good. And then I want x to equal pi on 3. You good? Everybody good on typing it in? All right, so negative 0.37223. So what do we know? F of x is decreasing because is less than 0. Oops, you can't see that, sorry. All right, so I want the same thing and I want it to be pi. So I'm gonna go back up here, hit enter, go to here, delete that out. What in the world? What does that mean? It's a what? It is a, what does a vertical, it has a vertical, yeah. Oh shoot, my little daggone, I put my pen on my paper, y'all, and that bled onto my, has a vertical, yep. All right, so vertical tangent there because it is undefined. Now, I haven't done any. I'll go back in a minute and do the graphing method on one of these up above just to show you. But again, I like the home screen better. All right, so if you did this, you ended up with f prime of pi being undefined. Okay, so since f prime of pi is undefined, f of x has a vertical tangent at x. Equals pi. All right, so take a second and go ahead and do E. Go ahead and do E. I'm going to go to, I'm going to go back to like B and do it the graphing method while you are doing that. All right, so while y'all work on that, just real quick, okay, I went into, just to do the graphing method, okay, so I went into Y1 and typed in, this is letter A or B, I'll do them both just to show you. All right, so A or B, so I typed it in, Y equals, I entered my equation. I'm going to hit graph just to make sure you can see my equation. All right, and then it says hit second calc, and we want to find the dy dx. So number 6 for us. Okay, and then whatever number you're looking for. So like on letter A, we were looking for -2. So I'm gonna type in -2 and hit enter. And then right there at the top, you see the same number, -0.538138. Everybody see that? If I typed in second trace 6 of 1, right there, there's that 11.268147. So either way will work. Okay, it just depends on which way you choose to do it. All right, what y'all get for letter E for your value? 0.3400. So what does that tell me? Increasing because all right, last one. Okay, so this last one here is, you do have to be very specific about how you enter this, okay? All right, so let's type it in. I'm gonna go to my home screen. Except for I just hit y equals, that's not what I want to hit. All right, so math 8, dy dx of, all right, 5. Sine. I don't like that. Let's try it, see what happens. All right, 5 sine ln of x, right? And then I've got to square that, right? I've got to square the sine. So that closed that. I've got to close that. Then I've got to square it. So that closes that one. That closes that one. Square the sine. Let's see. I need to square the sine, though. So I need to put a parenthesis over here, don't I? Right? What are we doing for 1? Yeah. Okay, so just so you see what happened here. Like, ultimately, we wanted, well, I'll write it on the paper so you can see. Ultimately, right, this square could be the sine of ln x quantity squared, right? Is everybody with me? That's where the square has to go. And then we're multiplying that times 5. Does everybody understand me? Okay, so that's why whenever I put it here, okay, I was looking at my parentheses. So this parenthesis right here, this parenthesis closes that one. This parenthesis closes my ln of x. This parenthesis closes my sine. Then I need to square it and then multiply it times 5.
Do you leave out like the parenthesis for the sign? It's going to be the same.
Did it? This one, all right. So hold on. Delete this one.
Yeah, you don't need that.
That one right there.
Mhm.
I didn't have it initially, but okay. I just didn't want to square the 5. That's where I was trying to make sure I was squaring the sign and not the 5. All right, so negative 5.000083 e negative 6. Y'all, what is that ultimately? What does e to the negative 6 mean? Times 10 to the negative 6, which means there are 6 zeros where? Before the 5. So ultimately, what is that answer? 0.000005, right? So we can say that is the same as 0. Okay? So basically, f prime of 1 here is 0. Okay? Well, if it is 0, what does that tell me about our function? It is an extrema or a horizontal tangent. Okay? So f of x has a, we would say, a relative extrema there, right? Because f prime of 1 equals 0, okay? It has a horizontal tangent at x equals 1.
Will there be cases where it just straight out gives you 0 after you...
Possibly, yeah. All right, we good? All right, last page. Nice big page for all the writing we're about to do. Not even calculating, it's just writing, really. The calculator does the calculating for you. All right, so let's see what we got. All right, when the value of the derivative of a function is positive, we say that the function is what? Increasing. When the value of the derivative is negative, we say the function is decreasing. Okay, when we talk about quantities increasing and decreasing, they do so at a certain rate. We already understand that the derivative is the what? Slope of the, good job, slope of the tangent line. And we know that slope is a rate. Therefore, ultimately, the derivative of a function actually represents the rate at which a function is changing. All right. So the number of people entering a concert can be modeled by the function f of t equals 560 e to the sine t, where t represents the number of hours after the gates are open. Find the values of f of 1/2 and f prime of 1/2. Using correct units, explain what each value represents in the context of this problem. All right, what is t representing? Okay, but what in the problem? It's our x, but what is it in our problem? The hours after the gates open, correct? So when we find f of 1/2, whatever we find f of 1/2 to be, once we get that numerical value, that represents, right, what? The people entering the concert half hour after the gates open. Does that make sense? Is everybody good there? Okay, if t was 3, it would be 3 hours after the gates open. Does everybody understand? All right, so let's go ahead and find f of 1/2. F of 1/2. So 560 e to the sine of 1/2. Did y'all get this number? Okay, so f of 1/2 equals 904.4819. Okay, that means, you can't see it. I'm sorry. Thank you. Appreciate it. All right, that means so that means that half an hour after the gates open, There are approximately 904 people. Y'all can use the approximately symbol if you want to there. Entering the concert. All right, so now we got to find f prime of 1/2, right? All right, what do we get for the for the derivative? 793.7573. Okay, so what does that mean? What does that mean? It's our rate, right? Okay. What type of rate is it? Increasing or decreasing? It is an increasing. Okay, so that means that half hour after the gates open, the number of people entering is increasing at a rate of approximately 793 people per hour. Sorry. All right, how many people have entered the concert 2 hours after the gates have opened? So which one do we plug that into?
Wait, this John.
Yo, what I do?
How come it would be 793 people per hour? I thought we done it
Do what? Per hour, not per half hour, is that your question?
Yeah.
Well, the thing is based on hours. The function itself is the number of hours after the gates open. Okay, so this is going to be the people per hour in general. Your rate in which they're entering. Not the number of people, the rate in which they're entering. So because your units were hours here, they're going to stay hours here. You're plugging in for a half hour, but your units is still hours. See what I'm saying? Like your original problem was per hour. Number of hours is your T.
Speed of a car. You don't take it per 2 hours or per 3 hours. It's always per hour.
Right. So like if you, yeah, like we don't say, oh, I was traveling 30 miles per half hour. My T in my T up here represents the number of hours. So whenever I do my final for that, T is still the number of hours. It's just that our T was a half hour, but it's half of an hour. Our T is still hours. All right. How many people have entered a concert 2 hours after the gates open? Are we plugging into F or F prime? F. There we go. F of 2. Okay, so literally, y'all just go back up. Go back up to here. And change that to a 2. There we go. I love that copy function. It's great. Pretty sure that didn't exist in the caveman days when I was coming up. The TI-83 existed, and the TI-83 Plus. We didn't have 84s. We had 89s, though. TI-89s. We had 89s. I don't know. I don't understand that either. It's right next to Andy. Andy, will you grab that and hand it to her? All right, what is it? 2435? We good? So approximately how many people are entering? About 1,390, so approximately 1,390 people And y'all, literally, we're just using the words in the problem. Are entering the concert 2 hours after the gates open. Is the number of people in example number 4b increasing or decreasing at that moment? Well, in order to tell me that, what do you have to use? The derivative. Well, I've already got it typed in. So I'm going to go back up here, and I'm going to put what here? 2, is that right? What is it? It is decreasing, so f prime of 2 is negative 578. So since f prime of 2 is less than 0, the number of people entering the concert two hours after gates opened is decreasing. All right, so I'm going to give y'all a minute to look at 5. So you've got 5, you've got the function, okay? Given to you right there. T of t, Lord, help me. All right, T of t equals 70 plus 110 e to the negative t over 2. All right, and it says, what is the temperature of coffee 5 minutes after it has been poured? Which one do we use for that one? We use f, right, the original function. All right, then is the temperature decreasing faster 1 minute after it is poured or 3 minutes after it's poured? Well, we're talking about decreasing faster, right? So if we're talking about decreasing, what do we need to use? The derivative, okay? So you're going to be, so for the first part, you're finding just t of 5, correct? Okay, then for the second part, you have to find both t prime of 1 and t prime of 3, and then we will compare them. So do the calculations, we'll do the comparison together. You do the calculation, we'll do the comparison together. All right, what was T of 5? Okay, good job. We good so far? All right, what's T prime of 1? All right, negative 33.3591.
It's 9.2.
Is it 9.2? Either way, I mean, I'm not. 9192. All right, what about T prime of 3? All right, so what can you tell me? In general words, I won't embarrass you. In general words. Like if you're talking to your friends.
Well,
What'd you say, Billy? All right, T of 1 is decreasing faster at T equals 1. Okay, I'll give you that. The temp is decreasing faster at T equals 1. Why? Now here's where you gotta be a little, it can be a little tricky, but why?
Because T prime of one is less than T prime of three.
Because the rate
Okay.
increase is greater at -33 than -12.
Okay, so yes, so in your mind, y'all did what you needed to do, which was realize that -33. Like a lot of people want to say, oh, it's decreasing greater, so that means that this is what they want to say. Just pay attention. You could say here's two ways you can say it. The first way I'm going to say it is T prime of 1 is more negative than T prime of 3. That's one way. Okay. The other way is what you said. Y'all said less than because, yes, value-wise, -33 is less than -12, right? Okay. But ultimately, the rate is a greater rate. Does that make sense? Is everybody with me? So in order to make it happen that way, what we're going to say, right, T prime of 1 is great, but is T prime of 1 greater than T prime of 3? No, but how can I make it? Absolute value, perfect. The absolute value of those does make that correct because the rate itself is greater.
Can't you just say it decreasing at a greater rate than T prime?
Yeah. But that's what I said there, just in different words. But say something because if you leave justify your answer blank, you get mad, Miss Johnson.
Now, if they were both positive, would we just not use that?
You could, right. Yeah, you wouldn't be incorrect to not use absolute value if they were both positive. You just can't do it that way because in your mind, this is what you're saying, but you have to have the absolute value because of the negatives.
Because
All right,
the
we
rate
good?
is always, decreasing or increasing, not the same as the.
Right. Hold on.